Hey everybody, my name is Aditya Thoma and my project is supply response asymmetry in the Irish house market. So my project basically looks at one simple question: when new homes are completed, how long does it take for that supply to affect property prices, and does this differ by area? So I have analyzed almost 8 lakh residential transactions across Ireland and link them with housing completion data from all the 31 local authorities. So I have two main questions, like at what leg is the relationship between housing completion and price growth strongest? And second one, does this relationship differ between urban and rural areas? So this matters because housing is delivered locally while targets are often discussed nationally, different areas can respond very differently. So what I did, I used three open data sources: the proper PPR, the property price register containing around 8 lakh sales since 2010, CSO data on dwelling completion by local authority and dwelling time, and the National Lake House Price Index, which I use as a control. I originally planned to use the permission but completions were a better measure because they represent actual delivery supply. So the entire pipeline was built in Microsoft Fabric. Profiles are stored in one lakehouse using a Medallion architecture. Bronze contains the original file, silver contains the clean data, and gold contains the final analytical output. So Spark handles the processing and the result are often are written to a separate lakehouse query through SQL endpoint. So there were three important cleaning steps. First, wet adjustment, new properties are recorded net to wet, while second-hand properties are recorded gross. Without correcting this, new builds would appear artificially cheaper. And I also removed non-arms land transaction and duplicate registrations. The biggest challenge, however, was assigning each transaction to the correct local authority. The biggest challenge, however, was assigning each transaction to the correct local authority. The PPR contain addresses as free text, while CSO data is organized by local authority. So a simple comparison would require hundred of thousands of addresses to compare against every possible locality. So I use three steps. First, country blocking to reduce the number of possible matches. Second, address segmentation because comparing the full address with a locality name produces poor similarity score. And finally, the min has LSH which efficiently finds similar addresses using character trigrams. This allows pipeline to handle the spelling mistakes, Irish English variation, and other inconsistencies. So the process is simple. The block segment and hash blocking reduces the search space. Segmentation makes similarity meaningful, and LSH allows only likely matches to be compared. So the process successfully placed 88.3 transactions. The unplanned records are concentrated mainly in Dublin Core Galway, where one county contains multiple local authorities. Instead of making a potential wrong assignment, the pipeline deliberately leaves uncertain records unmatched. It creates the area quarter panel, calculates dwelling type information, and task lags 0 to 16 quarters. The quality check is the panel match rate, which is around 90%. So the results are written directly into the output lakehouse and queried through lakehouse. Oh, sorry, SQL. And there are like three main analysis: the area quarter panel, dwelling type mix, and lag grid search. For the grid search, instead of running separate Python loops for every authority, I structure the data so that all the authorities and all the candidate lags can evaluate it together through Spark. And this is where the result become interesting. This is not a universal lag. Dublin City, Dublin, Laugare, that town saw negative correlations between completion and subsequent prices. But many rural authorities saw positive correlation at lag 0. For example, Roscommon is around 0.50 while the carry is around 0.041. The likely explanation is river cohesion. In areas where supply isn't high, constrained builders may build more when price is already rising. So supply may be following demand rather than causing the price movement. I then analyze what might explain these differences. The regression is statistically significant overall the with an R squared 0.38. Rural area so shorter estimated legs compared with commuter belt baseline. However, apartment share is strongly related to Dublin indicator, so I treat analysis as exploratory rather than casual. And one of the biggest lessons came from a bug that didn't produce an error. Dublin Postal District were initially treated as a local authority. So some records failed to join with CSO data. The pipeline is still ran and produced plausible results. The warning sign was the join rate dropping 54.7%. That taught me like an important session lesson. A pipeline that crashes is easy to detect. A pipeline that produces believable but wrong numbers much more dangerous. The main limitation is that the correlation not casual. I can identify when the relationship appears, but I can't prove the completion cause the price change. Future work, future work. So overall project demonstrate an end-to-end data pipeline using Fabric, SQL, Delta Lake, SQL statistic analysis. And the main finding is that housing supply does not behave the same way across Ireland. The relationship differ not all, only in strength but in direction. Thank you so much. Have a nice day.